Hello, good day viewers. Still on definite integrals. I've wanted to introduce Riemann integration, but I realize it is very important to learn how to apply geometry in finding the area between the x-axis and the curve, because it is somehow related to Riemann integration. So today, this is what we have. We like to find the area bounded by these functions: y equal to 2x plus 1, x equal to 1, and x equal to 4. We are not going to integrate, though we can do that, but I would like to show you how to apply geometry in finding that area. First of all, let us sketch this function. Suppose we have y axis like this, and we have x axis like this. To graph this, first of all, you need to locate y-intercept. This is y-intercept. Y-intercept is the value of y when x is 0. The moment you set this to be equal to 0, the whole of this will become 0 plus 1, which is 1. So it crosses y-axis at exactly 1. So you locate it here. So suppose we have 1 here, we have 2 here, we have 3, 4, and 5. So y-intercept will be here. So let me place a point. Then the slope. The slope is 2. You know that it can be rationalized as 2 divided by 1. So you rise 2, you move to the right once. So from the y-intercept, we move up 1, 2. They will move to the right 1. Once we place a point, we repeat the same process. 1, 2, move to the right 1. You can as well come down. We have 1, 2, 1. You place a point. You know, these axes are not accurate, but this is how to graph a linear function. They use a straight line to connect all of these points. Though I'm going to clear some of these points because they are not accurate. We don't have an accurate grid here. Something like this. So this is typically the function y equal to 2x plus 1. We can further extend it if we like, something like this. Then let us locate x equal to 1. This is not straight. Let me try my best. Something like this. X equal to 1. Suppose we have 1 here. Remember that this is 1 as well. And x equal to 4. Suppose we have it here. Okay, let me say 2, 3, 4. The graph of x equal to 1 is what? A vertical straight line. So it passes through this point. And y equal to 4 somewhere here. So let me connect this point. So we are looking for the area here. The area here. There are two different ways to find it. We may decide to partition the shape. I think this is trapezium. To find the area of trapezium, I know it is what? A plus B divided by 2 multiplied by h. This is the area of trapezium. So now let us apply this formula. Then later on, see how we can partition it into a triangle and a rectangle, because I can see that it can be partitioned like this. Find the area here, which is a rectangle. Then find the area of this, which is a triangle. Then add the two areas together. So let's start by finding the area of this trapezium. A is the length. Let me make it like this. This is 1. This is our A. This is our B. Then the height would be this one, which is h. The distance from 1 down to 4. So let me see, what is A? A is nothing but the value of y when x is 1. You can see it is exactly at 1. So it is at what? 3. Just look at it. This is 2, this is 3. We have 3. And what is B? That is when x is equal to 4. We cannot actually determine the value of y, but we can plug it here. If you plug in 4 here, it will give us 4 times 2, 8 plus 1, it will give us 9. So this is 9. And h is the distance from 1 down to 4. If you take the difference, it will give you 3 because 4 minus 1 is 3. So just plug it here. We have 3 plus 9 divided by 2 multiplied by 3. 3 plus 9 is 12, right? Then 12 divided by 2 is 6, and 6 times 3 is 18. Therefore, the area under the curve between these functions and x-axis is equal to 18. But let's try another way. We can partition it into two. This is a triangle to the top, and we have rectangle to the bottom. The area of this rectangle will be what? Base times the height. And you can see the height is 3, right? So it will be 3 multiplied by the base is what? 3 as well, because the difference between 1 and 4 is 3. So this will give us 9. So what will be the area here? It will be half the base times the height. It will be half the base times the height. So what is the base? The base is the same thing, 3. Because this is the base of the triangle, it will be the difference between 1 down to 4. You can even calculate it like this. 1, 2, 3. It is 3. Then the height will be from this point to this point. Already we have seen that from this to this is equal to 9 from here, right? But we know that from this to this is 3. So you can just subtract 3 from 9 and it will give us 6. So we are timesing by 6. 3 times 6 is 18. 18 divided by 2 is 9. So can you see the two areas, 9 and 9, making what? 18. Exactly the same. So if you like, you can partition the figure, which is a trapezium, to make it a triangle and a rectangle. But if you so wish to find out whether this is really true, you can integrate the function, which is what? 2x plus 1. From where to where? From 1 to 4. From 1 down to 4. Simplify and see. Definitely you have to get 18. So why do we want to know how to find the area using geometry? It's because of that Riemann integration. Because Riemann integration is nothing but an approximation. It is not an exact, rather an approximation of the entire area by inscribing rectangles of equal bases. In our next tutorial, you will see that definitely. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.